phi of x union y greater than x union phi of y. Okay, so this result we have discussed in the last class. So we can take the difference of that difference of these two functions, that is, what will be the result? This will be greater than or equal to 0, greater than or equal to 0, right? So now to prove the first and second result, let us call it as number 1, this as number 2. Number 2, we have to prove number 1 and number 2 proof. So let us take the left side, h of p union p dash minus h of p union h of p dash equal to expectation of phi of x union y minus expectation of phi of x union expectation of phi of y. We can take expectation outside. What will be the next step? Yeah, left side will be equal to expectation of phi of x union y. This is actually vector. Let us use this information. Okay, so we can take the expectation outside, so we can write like this. Okay, we can write like this, and you know, phi of x union y so we can use this information. Okay, and this is the result we have discussed in the last chapter. And for a coherent system, equality holds for the parallel system. So we consider this inequality, phi of x union y greater than or equal to phi of x union phi of y. Phi of x union y minus phi of x union phi of y greater than or equal to 0, so that we can so this is greater than or equal to 0. After substitution, we can see that this is greater than 0. If it is greater than or equal to 0, normally we can say that the left side is greater than or 0. That implies this result, that is h of p union p dash greater than or equal to h of p union h of p dash. Okay. Similarly, so we have proved the first result, that is equation number 1. So we can write it as equation number 1. This is nothing but equation number 1. Okay. Similarly, for the second result, we use the information that this is So this is the result we have proved in the last class. So we can use the computation of our theorem. So h of p into p dash minus h of p into h of p dash equal to expectation of phi of xy. This is vector. So this is we can substitute. So this implies what we can write the variation. Second minus less than or equal to 0. Okay. We can remove this 10. So this is the result we have already proved, and we can write like this. Okay. So what will be this one? Expectation of phi of x in x into y minus expectation of phi x into expectation of phi of phi. ഞാൻ പറയുന്നത് കേൾക്കുന്നില്ലേ അമൽ? ഓക്കെ കാണുന്നുണ്ടല്ലോ അല്ലേ? Okay.
Yes, sir.
So we can substitute this or we can take the expectation outside. So what will be the result? If you take expectation outside, you have what will be that result? You can remove this expectation. Yeah, this will be the next step. Okay. So so we can apply. We have already discussed that phi of x into y. Just remove this one. Okay. So this can be applied here, and then we can see that we can substitute the inequality here also. Now what will be the result? Yeah, this will be expectation of phi of x into y minus phi of x into phi of y, which will be less than or equal to 0. So automatically left side will be less than or equal to 0. Okay, h of p into p dash minus h of p into h of p dash less than or equal to 0. That means h of p into p dash less than or equal to h of p into h of p dash. So this is the second result. Okay, so we have proved two results. First one is h of p union p dash greater than or equal to h of p in union h of p dash. Now we consider the case that for a parallel system and for a series system. So we will continue like this. So for a parallel system, for a parallel system the equality holds, and for a series system equality holds in this equation. How it is possible? We know that for a parallel system this will be equal, automatically this will be equal. So as in the previous case we have these steps. Okay, so for a parallel system the equality holds, so here it will be equal, so also here it will equal, so automatically this will be equal. So we obtain equation number 3. Similarly for a series system, you know that this inequality becomes equality. That means this will become equal. So automatically this expression we have, and we can substitute. Then we can apply this equality. So this will be equal. So automatically after substitution this will be equal. Okay. What happens? So as a result it will be equal to p union p into p dash equal to h of p into h of p dash, right? That is the result. It's very fundamental, very important for the reliability operations in aeroplanes, jet engines, and whenever we want to apply what is redundancy in the system level or in the component level, this result is the fundamental for the application of such redundancy operations. Okay, so you have to understand the concept. Here we have only 1 or 2, 3 steps. We have already explained the steps. Okay, so here we can see one example. Look at this system, and the reliability function is given here, and for in the case of parallel and series are discussed from your home, no problem. Okay, anyway I will share this redundancy page with you. You can write it down in your notebook and submit to me today through Moodle. Okay, I will share this video after reaching my home.